Awesome. Hi, I'm Fraser. This is a project that was actually also just really recently funded, so thank you guys. This is awesome. I'm excited to be talking about it here today, but I'm warning you, I don't have results yet because it was just recently funded. I'm going to be talking about how we can formally model secure MPC deployment. Actually, not really. I'm going to be talking about the problem of secure MPC deployment, and then the question is about how we can formally model these things. Pardon me. Okay. So multi-party computation, or MPC, is probably something a number of you are familiar with. It lets multiple distrusting parties compute on their own, or someone's private data without revealing that data to others. So the classic example here is the millionaires problem, where we have a bunch of millionaires. They're very shy. They have millions of dollars, but they don't want to tell you how much they have. They don't want to tell one another how much they have. But for whatever reason, they really want to know who is the richest person. So without MPC, this is a very hard problem. They're going to have to, show one another their bank accounts, and it's going to be very embarrassing, potentially. With MPC, they're actually able to compute a max function over all their various wealths and figure out that the guy on the left-hand side is the wealthiest without actually knowing that, okay, the guy on the left-hand side has whatever it was, $8 million. This is just one example. There's actually, you can do kind of any arbitrary computation as a multi-party protocol, which is really, really cool. And it's rather exciting in this space too, because there are a bunch of very interesting applications. One that's become really popular is using MPC for building secure cryptocurrency wallets. So we had a talk a couple ago about how to keep private keys safe. Well, one approach a lot of people are using is to split them up into key shards and then do a multi-party signing protocol so that the key is actually never materialized anywhere, but you can still compute a signature and sign transactions. So you can sign the transactions without ever having the private key in memory. That's just one application. There are a whole bunch of other ones, people computing on private health information, stuff like that. Quite exciting. So now that people are actually using these things to protect millions of dollars or people's healthcare data, you might wonder, how can MPC protocols actually go wrong? Obviously, you can actually have the protocol itself be broken. That's happened a few times. The theoretical protocol just has a bug in it, fix the bug, hopefully the protocol is secure again. You can improperly implement a correct protocol. That's also happened. Just as with any other software bug, you can implement an MPC protocol wrong in a way that actually leaks the, say, private key. But the thing we're wondering about is kind of even more applied than just an implementation. It's what happens if you have something, a protocol, that works properly and that's implemented properly, and then it's kind of misused or deployed in a funny way. What security guarantees do you lose by doing that, and what does misdeployment actually look like? So I'm going to give a very simple example of, actually, not yet. First, let's talk about the sorts of assumptions the protocol could be making. So we might be assuming, all right, say all of our 3 millionaires are independent people, they're not going to collude in any way, given that our protocol is safe. But then if we actually go and find some millionaires on the street and we want to figure out who's the richest, maybe they actually do know each other, maybe they are going to collude in some way. That's not a great example, but this actually this sort of thing does happen in real life. So this isn't exactly an MPC wallet-related hack. This is more of a multi-sig thing, but the principle holds, and it's a really simple illustration. So you've probably heard of the Ronin Bridge hack. Lots of money lost, very devastating. And in this situation, we had a bridge that was secured by 9 separate validators, and they were allowed to act with 5 out of 9 approval. So that sounds pretty good in theory, right? 5 independent people have to come together and say, yeah, this bridge can do whatever in order for the bridge to do whatever. So should be okay. The problem here was that 4 out of these 5 validators were all controlled by the same company. So that's a bad start. That does not sound like independent parties. But okay, at least we're in a 5 of 9, right? But that 5th validator, actually, there was a validator that had delegated approval privileges to the same company at one point, and then they just forgot to revoke those privileges later. So they didn't intend for this company to have approval privileges, but they did. So now, just by compromising, I think it was Sky Mavis, you've got the entire Ronin bridge, right? And that is indeed exactly what happened. Very bad, lots of money lost. But there are more subtle versions of this kind of deployment that doesn't line up with the assumptions of the protocol, right? Like if I'm running a 3-party protocol, and I've deployed the software that represents each party on AWS in US East 1, and I wrote all the software, and I actually wrote the CDK that like deploys the different parties, and they're protected by the same sort of network firewall. Do I really have 3 parties, right? Or do I kind of have like one thing 3 times? Like that does not look like independence, right? So our question is, how can we model deployment, like protocol assumptions that the protocol is making, and how can we formally model how the protocol is actually being deployed and used in the wild? And since a bunch of wallets, for example, are using things like MPC, this seems like a really interesting time to try and see like, okay, are people actually deploying these protocols in ways that line up with the assumptions or not? And so our goal is first to be able to detect sort of vulnerabilities in wild applications, and then to also try and figure out safer ways of deploying these things and actually, not really proving that deployment is correct, right? Like, what do you even model at a certain point? Like, I'm not going to be modeling, I don't know, IAM policies for the people who are deploying this thing, but at least getting some greater assurance that we're using these protocols correctly in practice, assuming that they're theoretically sound in the first place. So happy to take questions. Yeah, thank you for having me.
Hello. It sounds like this could be similar, not just for MPC-based wallets, but also for like these powers of Tau ceremonies, or even in general validator decentralization. Do you expect differences in the modeling, or is that also part of your plan?
Potentially. Yeah, I think that's a really interesting direction. We're keeping it scoped on MPC to begin with, just because we have a sense of exactly what we have to model. So, okay, we're going to model the protocol at a high level, and then we're going to model these 5 different things about deployment to start. But I think once we have a working model, I think it would be really interesting to see if we could extend it to some of these other situations. And modeling things like multi-sigs should actually be easier.
Hi, nice talk. So have you ever considered debugging in MPC setting? Because sometimes debugging really requires you to actually look at the data to see what's going wrong. No, actually, never even thought about it, which is kind of funny because I also work on compilation for MPC protocols, where presumably debugging is much more important, but no. That's a great problem. In general, actually, for all these sorts of things, like proof systems, FHE, MPC, the question of usability, I think, has really mostly focused on better compilers or maybe better programming languages, but better debugging tools would be an interesting direction.
Thank you, Fraser.
Thanks.